Alright folks, it's Bass Action back in action here. In this video I'm going to go through some basics about bearings. Bearings are probably one of the most challenging parts of this chapter when we get to the word problems and how to draw them and how to know what you're really looking for. So we're going to go through some basics here. This first example is extremely simple, but is an important element to help emphasize some main ideas. Bearings will always be measured on an angle between a terminal side and a vertical axis. So that's going to be different than what we've been doing for a lot of our angles in reading our graphs up until now. So let's just jump into one and we can talk through how they're written and how we find the bearing. So if we have our origin, of course, is at 0, 0, and I want to find the bearing, and reading this language is going to be really important on these problems. That's going to go from origin to z. So I'm going to start at origin and I'm going to go up to z. Okay, so this would be considered my terminal side or my path of travel. The bearing for that is going to be off the vertical, between the vertical axis and that path of travel. So I can see on this that I'm going in the north direction, so just north, south, east, west like we normally would. Then we're going to write the angle measure of 15 degrees, and then we're going to write whether or not we're on the east or the west side of that vertical axis. So we're on the east side. Again, these first ones are going to be really basic. The bearing from origin to A, so I'm going to go from origin to A. Okay, then so I can see that I'm going in the south direction. I want to read the angle between the vertical axis and that path of travel is 45 degrees, and I'm still on the east side. The next one that we're going to look at is our bearing from origin to C. So we've got this path of travel. The angle between the path of travel and the vertical is going to be 50 degrees. So we're on the south. We've got our 50 degrees, but now we're on the west side. The last one will be our bearing from origin to K. Then we're going to have our angle between the vertical and the path of travel. So we're in the north direction. We have a 70-degree angle between the path of travel and the vertical axis, and we're on the west side. So those are just some basics on how we write the bearings. You might see them written in a different way in a different textbook, but this is how our book is going to write them. Now, down here in the bottom, you can see that I've pre-drawn some pictures, and you might want to pause and draw these pictures. It might help you follow along with what we're doing here. But we're going to look at how we can use a bearing, but then all the kind of different ways that we could analyze these particular problems. So up here in the words, we can see that we've got a pilot that's going to take off from runway 35, which has a bearing of north 35 degree east. So on all of these problems, I have my vertical axis on all of these scenarios. They're all going to have the same initial bearing. So it's going to be north 35 degree east. So you can see that I've gone to the northeast, and in each case, I've drawn in this 35 degree angle that is between the vertical axis and this initial path of travel. What I'm going to do on each of these scenarios is I'm going to change how the pilot turns and the distances that the pilot is going to go, what she's going to do in each direction. So on the first one, we've got the pilot that's going to go on this bearing of 35 degrees to the northeast. The pilot's then going to turn 90 degrees to the southeast, and the distances will be 5 miles, then 2 miles. Now, it doesn't have to be perfectly to scale, but it doesn't hurt to try to make it close. On our next one, same bearing, same 5 and 2, but the direction of turning is now going to go to the northwest. So we can see how these two pictures change just slightly. On scenario 3, we're going to flip the distances. Still the 35 degree bearing to the northeast, but the pilot's going to go 2 miles and then 5. So we're going to reverse these two sides in the triangle. And the last one will still be the 2 and 5, but we're going to do that turn to the northwest. So what we're trying to find in each scenario changes a little bit in how we have to think about this. Now, in this problem, the angles are going to be 90 degrees. We're going to have nice right triangles when we draw this. But when we get into problems later, it will not always be a nice 90-degree angle. So what we're going to do is we're going to finish off these triangles. So I'm going to draw in this third side here. I'm going to draw in a third side here. I'm going to draw in my third side here. And I'm going to draw in my third side here. Now, I'm going to fix a couple things as we go along, but let's take a look at our first one. The question is asking us to find what bearing should the control used to locate the aircraft. So we want to know the bearing from the control tower that was at origin to this aircraft out here. That means that the bearing that we're going to be looking for is going to have to be between the vertical and this path of travel. So I'm going to need this entire angle. So in order to find that entire angle, I need to find this angle right here. So I can go back to my basic geometry to find that angle in the right triangle. And I'm going to have a review of basic SOHCAHTOA in the next video. So if this kind of makes you feel confused, you'll definitely want to watch that. From this angle in the right triangle, I can see that the 2 is an opposite leg and the 5 is an adjacent leg. So what I'm thinking here is that the tangent of this angle is 2 over 5. So I can find this in my calculator by doing inverse tangent of 2 over 5. When I type my inverse tangent of 2 over 5 into my calculator, I'm going to get that this angle right here is 22 degrees, which means that the bearing for the control tower to the plane between the vertical is going to be the 35 plus the 22. So the bearing is still in the north direction. The angle is now 57 degrees because I'm going to add those two together, and it's still in the east direction. It's really important on bearings that you think and do not try to memorize. Let's look at the scenario number 2. Okay, remember the original bearing, that 35 degrees, is actually this whole angle right here. What we're trying to understand is that as my plane went this direction and then turned back, the plane is now doubling back on this initial 35 degrees. What we're trying to figure out is, has the plane, as it doubles back, did it cross this vertical? Is it now going to be on the west side of the vertical instead of the east? In order to find that, we would need to find this angle that's inside the triangle. Is this angle inside the triangle more or less than 35? Now, we already did the math in the last problem, but if we think about, okay, what would we do if it wasn't already there? We would again say that the 2 is the opposite because it's a right triangle and the 5 is the adjacent. So we would again just do this inverse tangent of 2 over 5. We would find that the angle again inside the triangle is 22 degrees. So we would say no, the pilot did not go across the vertical. It's still on the east side. So our bearing is now going to still be from the vertical, but is now going to be this small angle that's right here. And that's going to be the difference between those two. So this bearing is still going to be north. It's going to be the difference of the two angles of 13 degrees, and it's still on the east side. Okay. Now let's look at the next scenario down below. In this scenario, slide this up a little bit. In this scenario, as my plane is traveling, it goes up 2 and down 5. Now I'm trying to figure out, is it crossing this horizontal? As the plane is heading in the south, okay, heading the south direction, did the plane go far enough to cross this horizontal so my bearing would now be in the south? So what we're going to do to figure that out is we're going to find this angle right here, okay, and if these two angles together are more than 90, then we know they've crossed that horizontal. So again, from this point of perspective here, now we're going to have the 5 is the opposite and the 2 is the adjacent. So now we're going to do inverse tangent of 5 over 2 instead. And when we type that in our calculator, we're going to get that our angle is 68 degrees. And now we can see that, yes, the pilot has gone past that horizontal. So we're going to go ahead and fill in this last angle right here. Of course, these three together should all add to 180. So we can fill in that angle as 77 degrees. So the bearing from the control tower to the plane is going to be between the vertical and that, again, path of travel. So now our pilot is going to be heading in the south direction because it's on the south side of the horizontal, 77 degrees and east. Our last scenario that we're going to look at, again, that 35 degrees. It's always important to give yourself some colors or some marks to remind you the 35 applies to that. as our plane went in this direction and then started doubling back, we want to know if the plane crossed that vertical. So if the angle inside the triangle, this angle here, is more than 35, then the pilot did in fact cross the vertical axis, which would mean the pilot's going to be on the west side. So we've already done that math. It was our inverse tangent of our 5/2. So that got that angle was 68 degrees. So sure enough, our pilot did cross the vertical. So the new bearing is going to be from the vertical to the control, or to the plane. So now it's going to be this little difference here, the 68 minus the 35, or 33 degrees. So the pilot's going north, the angle is 33 degrees, and it's going to be on the west side of that vertical axis. We're going to do a lot more work with bearings, but this is a good, important foundation that you need to have.